The last video then on functions and their transformations. There are other shape equations that you have to be able to sketch or recognize other than parabola curves. So by here, this shape shows us that the highest power is x cubed. So if we had x cubed plus 2, x cubed plus x cubed plus 4x minus 1, all of those have x cubed as the highest power, and so would give us this shaped curve like an S on its side. With the first one by here, it passes through the 0, and so it's simply an x cubed, so the function of x is x cubed. But we can have them so that they're sharper and that the zigzag shape in the middle goes higher and lower, or we can have them the S backwards to the normal shape, in which case it's a negative x cubed. Remember, in parabolas a negative wouldn't affect them because a minus 2 times a negative times a negative is a positive, and a positive times a positive is a positive. So if we had minus 2 squared, it would be the same as 2 squared. In this case it's different because minus 3 squared, a minus times a minus times a minus would give us a negative, and a positive times a positive times a positive gives us a positive. So actually having a that's why having a negative function flips it left right, whereas with a parabolic curve, a negative function flips it in the x-axis. So that's cubic functions and what to look out for. This function then is a reciprocal, so 1 over x. So for instance, if I had where x is 1, 1 divided by 1, y would be 1. Where x is a half, 1 divided by a half is 2, so y is 2. Where x is, say, 10, 1 divided by 10 is a tenth, so y is a tenth. So what you can see here is one little thing to note is that it'll never quite reach the y-axis or the x-axis, because we can never have x being 0. 1 divided by 0 is infinite, and whatever the number is, no matter how big the number is in the x, you're always going to have something left over. So if it was a million, it would be 1 millionth. If it was a billion, it would be 1 billionth, and so on. It'll get infinitely close to the x-axis, but it will never touch it. And then we've got the negative equivalent. So this would be 1 over minus 1, 1 over minus 2, and so on. If this was the negative form, if the function of x was 1 over x and we had to plot the minus function of x, then the two curves would simply be in the other axes. The final one we need to be able to recognize is 1 over x squared, where the difference is that because a negative squared will give us a positive, in the last graph we could have y's of a negative value. However, in this one, whenever we have a negative x, squaring it makes it positive, so we've only got y's that are positive. So instead of having a curve here in the first quadrant and in the third one, we've got in the first and second, where y is always positive. A couple of other graphs then. We've done cosine, and tan in algebra, but we might want to, when we did that, we looked at how we can have sine 20 degrees an angle, and that would give us a particular value. So we might be able to want to plot that in a graph, and if we did that, we would actually get this pattern here, where sine passes through the 0, goes up to 1 at the value of pi divided by 2, down to 0 at the value of pi, and down then to minus 1 at the value of 3 pi divided by 2 and back up to 0 again. So it follows this pattern going along, but importantly, it goes to the 0, through the 0 and up to the 1. With cosine x then, it starts at 1 when x is 0, makes it so it passes through the curve at pi divided by 2 and down to pi when it's minus 1, and repeats the pattern. So when we look at those two graphs, the sine x is on the left and cosine x is on the right, we see the difference is that it's just moved over slightly. With sine, it passes through the 0 and makes its way up to 1. With cosine, it starts at 1 and makes its way down to 0. So make sure you can recognize those graphs and by which one is passing through the 0 and be able to plot them on a graph as well. Our final one is tan then. So whenever you see this pattern where it's not quite reaching the pi divided by 2, then, or 3 pi divided by 2, we've got the tan of x. So if it's got this strange S shape passing through pi, 2 pi, 3 pi, 0, and then not quite reaching pi over 2 or 3 pi over 2, that means it's the tan x graph. A lot of these, you just have to be able to recognize them rather than any complicated function with them. You certainly don't have to do any transformations with tan x. So we can actually, we've done about transformations, but you can actually do this with other functions. So for instance, with these ones, a linear graph, we simply move the graph up 2. So whereas this should be the function of x to start with if it went through the 0, moving it up 2 would be the function of x plus 2. We're adding 2 onto the function, just like we did with the parabola curves in the last video. Similarly, we've got a cubic graph by here where it would have passed through the 0, but it's moved up 4. So as a result, the equation is x cubed plus 4, or f function of x plus 4. So the things that we do to a parabola curve will have the same effect on other curves such as linear and cubic. We have to be able to recognize and plot transformations with both linear, parabola, and the sine and cosine graphs. So this by here then shows us the what we might think are the two graphs of sine and cosine, because one goes through the axes at 0 and one goes through the axes, the y-axis, at 1. But actually what I've plotted here is the sine graph passing through the 0 and its transformation of f of x plus f of x plus minus 1.8. Sorry, quick calculation there, and I probably calculated it wrong, but minus 1.1235 even. That was a terrible calculation. Thank you. So f of x minus 1.5 moves it to the left. So again, the sine and cosine functions can be moved left, right, up or down, just as we have with other functions, or their gradients can be made steeper.